was showing absolutely 100% here, and for some reason my microphone wasn't working. So forgive me, but I'm going to start from the top again. Welcome to Intelligent Automation 2020. I'm Mark Stephen. I'm going to be chairing today's event. If you're going to be tweeting at any stage today, you remember to use the hashtag #AutomateSummit. It's worth pointing out that today's activity is 100% live. There are no pre-records on this at all. Now, the implications of that are quite simple. If you ask a question, you can reasonably expect to get an answer to that question, and you can get as involved as you choose to be. We've transferred as much of the value as we can from the physical events into this virtual environment. So there's presentations, discussion and networking via live chat facilities. You can also meet solution providers from across the supply chain in the exhibition area. There are a number of competitions and prizes on offer with a leaderboard to let you know how you're getting on against the competition. Just click on the leaderboard icon in the lobby to get involved. Exhibitors are also giving away prizes at their booths, including Amazon vouchers, Bluetooth headphones, a £100 restaurant voucher of your choice, a £50 whiskey voucher, which would be my personal favourite, and a pair of iPods, because a single iPod is worth than useless. Please take time to explore the platform. It's actually remarkably well put together. You can engage with the sponsors and make the time to chat with your peers throughout the day. There are 3 chat environments in the networking lounge you can join. They are ethics and bias in AI, automation and the COVID effect, as well as introduction networking. Now, the conference sessions will be run through a series of webinars. To access the sessions, navigate to the auditorium page and click the session you wish to attend, or select the hyperlink in the pop-up boxes, which appear immediately before the main sessions. Just before I get into the meat of this, it's worthwhile pointing out that Digit's next virtual conferences are in sequence: FinTech on the 29th of September, Digital Transformation on the 28th of October, and Data Protection on the 10th of December, and all of those will be held online. Now, the morning sessions today will contextualize the advancement of intelligent technologies, exploring how AI, machine learning, Internet of Things, and robotic process automation have actually evolved over time, and illustrating their impact across a range of fields. Our first speaker today is Sarah Mannion, who's a technology evangelist in NVIDIA. The title of her talk is Smart Manufacturing, Real-World Examples, and the Technology Driving Them. So, Sarah, over to you.
Thank you, and good morning, everyone. So, I'm Sarah from NVIDIA, and I want to talk to you about one thing today, exactly that: smart manufacturing and some examples, real world, of where it is in use. I want to start with, what do I mean by smart manufacturing? And I'm using this image because I think this is what most of us think if you think of smart manufacturing. We're all very familiar with these robotic arms. They've been building cars for decades. You know, this isn't anything new. What I mean by smart manufacturing is machinery that really is intelligent and is aware. So these robotic arms that you have in the factories, they can't understand where they are. They don't know that there are other machines, there are people. They can't do a different task. They can only do what they're programmed to do. And so this is really what we're talking about. Smart manufacturing, to have machinery, to have devices that is intelligent, that is aware, and that can act depending on what information or data or environment it's in. So to give you a couple of examples of where we are seeing this, and there's really, I think, 3 main areas that we're seeing an awful lot of interest and we're seeing a lot of deployment. The first one of this is really around, looking at industrial production and production lines. And what we can see here is production lines. So using technologies like computer vision to check that everything is as it should be. So an intelligent system that can have a look at the entire production plant and see if every single component is meeting standards. The other area is smart maintenance. And that really is around being able to predict faults, cracks, etc. And the other area that we really see a lot of growth in is around smart logistics. And that is really what I want to talk to you about today. And that is some of the examples that I want to start with. What do I mean by smart logistics? And logistics in terms of inventory and supply chain. I'll start off with an example, one that hopefully many of you here will recognise, and that's Ocado. We've been working with Ocado to help them deploy a truly smart logistics environment for their warehouse. And this is really, really interesting because Ocado pack 250,000 orders a week, so quite a lot. And they have over 50,000 line items. So, you know, a huge array of products that are potentially going to be picked and packed in that environment. And we've helped them to deploy computer vision and have trained this environment to understand every single one of those line items. And this really helps by making a smart, intelligent factory. Why and what do I mean by that? So if we need to pick and pack a variety of products and someone has put dog food into the area that's supposed to be tinned tomatoes, a tin looks like a tin and you might be forgiven for picking up the wrong item. By using the computer vision, the system is trained to understand the difference between a can of dog food and a can of tinned tomatoes, so it can ensure the right products are in the right places and are going to the right distribution points. And this has saved Ocado absolutely thousands and thousands of pounds on missed stock. You know the example of the wrong shipment has arrived because it was in the wrong place and picked by the wrong person. So this is what this system is trying to prevent. But it's also going a little bit further than that. And another area that they're using the system for is to understand what those products are. And every single product in that 50,000 lineup of products has been put into a system, a smart, intelligent system, and it's trained to detect and identify all of those products. So when it's doing the picking and packing, it understands what it's picking and packing. Why? Because you don't really want to have a system that picks up a nice soft punnet of raspberries, say, and puts a 4-pack of beans on top of it when it's picking your packing and shopping. You don't want damaged goods, and Ocado don't want damaged stock because it costs an absolute fortune and it's a waste. So the system is trained not just in what the products are, but in understanding them. So it knows not to put a heavy item on top of a soft product item. And so this is really, really helping Ocado to avoid damaged stock, saving them lots of money, but also ensuring that they get the right product in really good quality delivered to the right places and hopefully delivered to all of the customers as well. So that's one area that we're working with Ocado on. And another area that I want to share with you is about what happens in the actual warehousing. And we call this around, intelligent storage, intelligent retrieval. And as I say, this is taking it a step further to having robotics that can go and collect whole pallets of goods. But these are intelligent devices. And this is really a huge growing area. This is really what I want to talk to you about, because this stuff is really, really exciting. We're probably all familiar with having pallet trucks and people driving pallets around warehousing. These are solutions that look to replace that, but with smart robotics that can navigate the entire warehouse or factory and can take goods to where they need to go. And you can probably program something to do that. But the difference here is that these systems are smart and they have a map of the factory built in, so they understand where they're going. They can navigate around obstacles and they can do some really, really smart things. So Ocado is one of our partners working with us to install this smart storage and smart retrieval of products in the warehouse. But I wanted to highlight another to you, and that is BMW. And BMW are really sort of, I guess, flying the flag of really putting some smart solutions into their warehouses. They've actually built 5 different robots: SplitBot, PackBot, SortBot. So there are different robotics for different jobs within the warehouse. And what you can see here is Smart Transport Robot. So very similar to the Ocado one. It's designed to bring goods and deliver them around the store, around the warehouse, sorry. And why is this needed? So if any of you have a BMW and you've gone onto the BMW website, you might have seen that you can design your own car, and to an absolutely minute detail. You can choose, not just the wheels, but you can choose all the different trim and, all sorts of different customizations. And this is a fantastic thing, but it means of all of the factories in the BMW plants, they need to have different types of product, and there's no seasonality or pattern to it. A consumer or customer in Munich might want something the same as someone in Cologne. So all these parts have to be sent around to different locations, and it doesn't follow a statistical pattern. So this is why BMW are investing in these robotics, to help facilitate the movement of all of these products and to check that the right products are going to the right places. And what I want to do is show you a little bit about how this works, bearing in mind that there are something like 31 million parts from 4,000 plus suppliers that these robotics sort out and make sure go to the right place. So what I want to do is just share with you a little video to show you really what it's like in action.
I did say right at the beginning of this that we are live, very live on this, it would appear. Obviously, Sarah has frozen up. What we've asked her to do is to log off. And then, I don't know, did you hear the beginning of that? Possibly not. I don't know. As I said at the very beginning of this, this is live. It's extremely live. And by the looks of it, Sarah's feed has frozen up, as you might expect. We are hopeful that fairly soon we'll get it back up again. Sarah, is that you?
Yeah, is that me back in again?
Yeah, it sounds awful like it's you back in again, right? Do you want to pick up, what I would suggest doing, if you can, I don't know whether you can or not, do you want to start at the beginning of that video again?
I can try, yeah, I'll do that.
No, right. Well, tell you what, no, I'm getting waved at by Pete in the background saying, no, don't start at the video. Take it from the end of the video. It's probably the best thing. We've got about halfway through it, okay? No, I'll leave you to it.
The video is might have been why the audio was lost. We can share the details of that with you, but if you want to look it up, it's publicly available, and it really is showcasing what we've been doing with BMW and how we've been building these robotics. Now, I'm sure some of you are thinking, okay, what's the NVIDIA connection here? Something to do with GPUs, and you'd be right. Our platform, of course, starts with a GPU. And all of the devices that you've seen, so the smart robotics, all have GPUs embedded in them, very, very small ones. And they are the brain, or the decision-making part of the technology. GPUs are processors, parallel processors, and they are used to do all the decision-making so that that's done locally on the robot, and there isn't a reliance on having to go to the data center. But it's not all about hardware. So, of course, we have the GPUs in the robotics, and we have some in the data center for doing all of the training so that we can train these systems. And that's hugely important. The Ocado system can't recognize 50,000 line items without being trained on every single one. For Ocado, we actually used CAD-generated images of a lot of the products. So we didn't need physical tins of everything, but of course that training needs to be done. What happens on top of the GPU is actually a little bit more important, and that's the software. And that's the other thing that I want to talk to you about today, because what you've seen so far with the robotics is all using our NVIDIA Isaac SDK. And this is software that is free and publicly available, and it is basically the environment to build autonomous robotics. So this is absolutely free and publicly available. And that's what BMW and Ocado have used. But there's one thing I would like to share with you before I wrap this up, and that's JARVIS. And I want to share this with you because I think this is going to be a real future of smart manufacturing. And what is JARVIS? It's an SDK, so an environment for building conversational AI. And we all know this, I'm sure, from Alexa, Siri. Apologies if I've just set anyone's off at home. We have a framework, and that allows you to build your own applications. And you can go and download it from our website. The thing that's different here with a lot of the commonly available audio assistants is that there's no wake word. It can track multiple conversations. It can connect multiple conversations together, and it's aware of its environment, hence the multimodal. And we see this as being hugely impactful in manufacturing. And I'd like to show a video, and I hope that this works. It's only 20 seconds long, but rather than me talking, I think this will really explain what it is. So let me just share this with you.
The NVIDIA backpack is $100. The NVIDIA backpack is $100.
What about the one on the right?
The price of Hex tote bag is $120.
How much is the white bottle?
White Contigo bottle is $21.
Is the black one insulated?
Yes, black Contigo tumbler is insulated.
What's the size of the center one?
Rose Swell bottle can hold 15 ounces.
Okay, great. I'll take that.
Perfect, I'll charge it to your account.
So hopefully that all made sense. what we see is these technologies are really going to come together in manufacturing. Autonomous robotics that you can talk to. So imagine being able to say to the robot, can you take that pallet over there? No, not there, next to the blue one. Or can you bring that here? And these are some of the technologies that we are working with some of the leading organisations to bring to fruition. So that's me. If you want to know more, head over to the developer section on our website. But I'm going to stick around and have a look at Q&A, and I'll be here to do some questions at the end of the year. So thank you for listening.
Okay, great. So I'm told you can see my start slide. So moving on from what Sarah was talking about, I want to talk to you about something rather more out there and organic. How we go from being at the behest of the weather to absolutely agriculture 4.0, and how we guarantee to get the food that we want on our plates. So a little bit about the business. It's a 7-year-old business founded by a farmer. It's in the space of agri-tech, specifically indoor ag, and even more specifically focused on vertical farming and on the provision of far better climates in spaces like polytunnels and greenhouses. We've invested a huge amount in the last 7 years in R&D, have filed a whole bunch of patents, and we have totally productized something that up to now has either been utterly organic or has been built by custom builders. The evidence for what we have is not coming from my mouth. It's coming from the fact that the 3 most active agri-tech VCs in the world, Osprey in New York, AgFunder in Silicon Valley, and S2G in Chicago, have scoured the world for the optimal platform to invest in, and they chose us in little old Invergowrie. So people talk about controlled environment agriculture, and you can imagine the degree of control that was implied in everything that Sarah talked about. We're talking about total control, complete precision, using automation and IoT-enabled devices, using AI and ML in very, very groundbreaking ways, which I'll explain to you in a minute. The benefits are things like far, far greater yield than traditional agriculture, environmentally friendly, and very, very lean on the use of natural resources. So what is a vertical farm? Just imagine taking a field and cutting it up into trays the size of snooker tables, stacking them up in 2 stacks inside a 9-meter high tower, stick them in a box, which is the farm, make the climate, and then control it from your mobile phone. That is a vertical farm. Our other product, the Intelligent Grid, is actually where the business started. So our farmer founder was looking to extend the growing season where he was growing in the north of Aberdeenshire, and that'll make Mark laugh, to 12 months of the year. So we all know we get long summer days, but we get very short winter days. So the need was there for extending the summer climate inside this enclosed environment, and particularly extending the light. So the idea was to create this intelligent grid which replaces cables, cable trays, and you can hang from it any sensor, any camera, any light, and you can go further and take it into people environments. So we own a global patent to replace existing systems for communications and power and monitoring and lighting in any building of any type. For example, car parks and retail, but not limited to that. Hospitals, railway stations, airports, anything that you care to think about. We apply it in horticulture to deliver benefits during the growth stage, and take the cycle down by about 1/3 by extending the growing hours by 50% and massively reducing waste. In retail, we can have a completely different interaction with the consumer, but we can also lower the OPEX through energy saving and lower the CAPEX because the materials are simply a lot cheaper. And you don't need an electrician to install it because it runs at 40 volts AC and is completely safe to touch or to reconfigure. And in car parks, maximizing the use of the space, driving revenues, and making sure that air quality is also optimized. But I'm going to focus on agriculture, and I'm going to focus on how we do this, particularly with the vertical farm system. So we've set ourselves 3 targets. If you're going to work in the food industry, you have to deliver excellence of quality. If you cannot do that, don't bother putting the seed in the ground. Secondly, you have to deliver for the farmer a farm gate price at which they can produce food that is economically competitive and gives them a significant margin versus local wholesale prices. And finally, everybody now wants to do this in an environmentally friendly way. Whether we're coming out of Brexit, whether we're coming out of coronavirus, people are also saying we've got to get sustainable, because the single biggest polluting industry in the world right now is agriculture. And that is what causes us not to be able to grow our food because of climate change. So it's a negative circular economy at the moment, and we have to flip that on its head. At the moment, some parts of indoor ag are automated. You can see seeding and harvesting and packaging equipment here. But this growing area looks Victorian because it largely is Victorian. So what we need to do is to replace this old-fashioned ebb and flood, sodium light, really inefficient system with something much more efficient. So how do we get to the number that? What is it we have to be able to do to make that happen? Well, we need to understand the weather, because the weather and then the climate are the single biggest impacts on what a farmer is able to grow. So think about the weather as a three-dimensional thing: the sun, the wind, and the rain. Turns out, guess what? It's not actually that simple. So each of those three dimensions has multiple factors. There's lots of ways of thinking about what's in our water, how strong the wind blows, what the temperature is, how humid it is. And in the sun, for example, we have brightness, we have length of day, we have all kinds of things. But the point is that each one of these factors has an almost infinite number of possible values. Take spectrum, for example. Think about going into a DIY shop and looking at the color charts, and it's bamboozling. Well, the light that goes onto our crops is exactly the same. There are incredible possible varieties of spectrum, never mind brightness and all the other aspects of light. So my point here is this is complicated, and it's very, very big mathematics, which is why we need automation and why we need AI. When we think about the sun, we deliver the sun on the bottom of the trays. Each tray, which is 6 square meters, has 21 strings of 19 LED clusters, each cluster having 5 differently colored LEDs. And we can deliver all these benefits here because we can do that, but also because of the way in which we can control it and automate it. And so in each of our towers, there are something like 100,000 individual LED lights. That's a massive electronic and electrical challenge. When we think about the wind, we think about near-field wind. So the LED lights are only 70% efficient. We use the extra 30% to warm up cold air that we push in through the base of the trays. We then deliver very, very even exact temperatures across the trays. But we've put living things inside a metal box. And that's a big clash between something living, breathing, and organic, and something that is static and solid. So we have to manage the gas mix, we have to manage the humidity, we have to manage the temperature. And so managing the ventilation is not just about the wind, it's about a hell of a lot of other parts. And as you can see here, we're now able to do that to within less than 2% tolerance. And that is easily enough to make the plants happy. This data is from about 2 weeks away, and it's our target temperature and our target humidity levels inside one of the towers. Then we think about the rain. So this is completely automated. It's on a little lift, which is raised and lowered by 2 BMW motorbike belts, believe it or not. And each tower has its own irrigation system, delivering it on ebb and flow basis. But the really exciting thing is that everything the crop does not take up, we capture. So the runoff is captured and put back in the system. The water vapor is captured, condensed, and goes back into the system. So in somewhere like a desert environment, we have an extremely efficient use of water. And the only water that leaves the farm is actually in the body of the crop itself. We run 20 cycles a year, roughly. We use 5% in each cycle, so we only replenish our water once a year. So those 3 dimensions are great, but they're not enough. We need to think about the 4th dimension of time. So as we automate the process of growing crops, what the crop needs at the beginning, when we are seeding it and germinating it, is warm, dark, humid environment. when we are hardening it off at the end of its life cycle, it needs cool, it needs brightness, and that will massively extend the shelf life and massively harden it up for planting out if, for example, we've been growing seedlings. Then we have to think about the diurnal range. So we have to think about ambient nightlight, we have to think about sunrise, 18 hours of perfect weather and a sunset. And if you can't do that, you're not at the races. And then we have to think about the seasons. So we want to be replicating late spring to early autumn when most things grow. That's not enough. We also have to think about space. So each one of these trays is a microclimate. They're 30 centimeters apart, but they can be 6 degrees Celsius separate from one another. So the green one can be 6 degrees warmer than the blue one and cooler than the orange one above it. Then we have to think about the difference between a tray and a tower. So if a tray is a microclimate, a tower is an independent farm with its own energy supply, its own irrigation, its own background HVAC. Then we have to think about the space in which we place the seed. The one at the back is for potatoes. The one at the front would be for beetroot or chilies or something like that, or lettuces. And then we have to think about space in terms of a climate. So weather is one thing, but where you are in terms of latitude, where you are in terms of proximity to the sea, to altitude, all these things have an impact on your ability to grow. How can we do this? Well, we do it because we own one of the most fundamental patents I've ever run across in recent years. So every LED that you've ever looked at, so if you hold your camera up to an LED or a telly screen or the slide screen at a conference, you will see flicker or you will see lines across it. That's because it's running on single phase electricity. So number one, the white one here is going on and off, and it's doing so 50 times a second. That is not good for the LEDs. Also, it creates flicker. We can't see it. Our mobile phone cameras can. The plants can. And turns out chickens can. So we need to remove that because it's not good for the system and it's not good for the crops. So we have patented the ability to use low voltage, three-phase electricity at running at about 40 to 50 volts AC, which we then take into a DC wind waveform, and we skim the top off it. So we just use the green DC at 65 to 70 volts, and that is what powers our LEDs. So they never go through zero. And as a result, we get these brilliant crops. So we're growing roots like baby turnips, radishes, and potatoes. We're growing fruits like chilies and strawberries, and we're growing the leafy greens and microgreens that everyone else can grow. That's great, and the data that comes from it is great, but it's only useful if you can act on it, and you can only really apply it in agriculture when crop science and industry come together. So we collaborate with the James Hutton Institute to achieve that. So how do we do this? How do we actually manage this thing? Well, first of all, we create a weather recipe. Then we apply it. We measure what actually happens. We learn from it. Build, measure, learn. You guys have seen this a million times. So we're iterating recipes of weather, recipes of climate, recipes of the whole 5D thing. So we then generate a new experiment. We apply that in terms of light, wind, and rain. We watch what happens to that weather by monitoring it. We look at what happens to the crops in reaction to it. We look at what's happening to the machine, because we don't want to put human beings in the machine because they bring pest and disease. So we have to monitor that remotely. We report on the exceptions. We quantify what's happened to the crops better or worse than what we expected across a whole range of values. And then we use AI and ML to create a new weather recipe and so on. So what potential does this give us? Well, it gives us the potential to draw energy as a service. Energy is 77% of the cost of running one of these things. What Sarah talked about in terms of a car plant, if you stop a car plant halfway through a weld, you have to throw the car away. Turns out that with crops, you can stop and start and stop and start. So it's one of the very few industrial processes that can respond to electricity prices and flex with the grid. So you can give the electricity company control over when the thing is switched on and off. We've taken out all the IT, and we've very, very much simplified this and put everything up into the cloud. We've recognized that all the variables are interdependent upon one another. And so by managing them as a whole, by managing the whole thing as a system and a machine, in the case of this, we're able to optimize productivity, which we define as things like yield, quality, and consistency. And then thinking about robotics, well, we handle all the trays, all the racking, all the movement of the crops on an automated basis using robots. But then picking them is really, really physically hard, especially with things like tomatoes and strawberries and so on. But the first challenge is finding them. So our system can find where the fruit is. It's then up to the robotics guys to figure out how they physically pick it. But this is where the whole industry is going. And what will this deliver for us? Well, Agriculture 4.0, farming as a service. No longer is the farmer at the behest of the weather, wondering if I can grow it, will it be any good, will I get enough yield, and then going cap in hand to a buyer in a supermarket and saying, how much will you give me for this? We've taken that away. So imagine a farmer growing stuff in a vertical farm on a 9-year subscription with a major supermarket chain who say, you fill those shelves with these products and keep those shelves full all the time to a given quality, and we will simply pay you a quarterly subscription fee. No negotiating on prices. You guarantee delivery and quality. We guarantee you economic viability and an income. That is Agriculture 4.0. That is what AI, ML, and automation can bring to the table. And our little Omron robot there is there to move things around and be part of the whole automated process. Thank you very much.
Good, fine. Can I suggest that you just start? Okay, we'll take it from there. I've introduced you, or I've tried to introduce you several times, but if you go and just do your presentation. Thank you.
That's wonderful. Okay, hi everyone. So let me get into this. So I will be talking about AI and IoT on smart cities development. So let's give some information first. So 270 billion, that is the cost of energy waste. The built environment is responsible for 80% of consumption globally. And because we're going to have a lot of people moving from rural areas into metropolitan areas, we're going to have to build every single day 2,000 apartment buildings, each one with capacity for 90 people, and most of them will have to be affordable. 173 billion, that is the cost of food waste. We throw away 500 trillion euros throwing water that we water the food that we are going to throw away. We throw that away. And 1 in 4 cities around the globe is experiencing water scarcity. And while we throw away all that food, 1 in 9 people around the globe, they are undernourished. And every 15 seconds, a child dies because they have nothing to eat. 100 billion pounds, that's the cost of congestion. We have, as of today, 1 billion cars on the street. In the next 10 years, we're going to double that number. And a driver, in average, spend 4 to 6 months of their lives trying to find a parking space. And 96% of the time, the cars are not used. They're just parked. And 81% of the time, those cars are not filled to its full capacity. It's just like one driver for a car that you could have like 4 more people. 100 billion pounds, that's the cost of pollution. We have 92% of the world's population, that is over like 7 billion people, exposed to very high level risks of pollution. And we have every year 3 million deaths associated with air pollution. Air pollution does not only gives us problems in our respiratory system, but it also causes us cognitive impairment. A study done in Israel found that kids exposed to pollution levels in comparison to kids who didn't. So the kids who did had high exposure to pollution, they performed much worse on exams at school, and that impaired their ability into joining good universities. And the cause of air pollution is the inefficiency that we have in city environment. 270 billion, that's the cost of waste. So next time you think about fast fashion, think twice. So we, as humans, we consume 1 million plastic bottles per minute, and less than half of that gets recycled. Only 7 bottles become, 1 in 7 bottles becomes recycled, and all the rest ends up in the ocean, killing sea life. And if you have a diet that is based on seafood, you consume in average 11,000 tiny pieces of plastic every single year, because, you know, the plastic we throw in the oceans ends up in our body as well, making us more sick. 70% of the world's population don't have access to safe surgical care. We're going to have a shortage of 2.3 million physicians around the globe. And 70% of the world's population, they're going to be living in cities. So it's 2.5 more billion people coming to live with us. And that is a trend seen in all continents across the globe. And we know that the majority of people are going to be living in those blue dots that are the largest cities. Sorry. Someone must have clicked. So we have people living in those blue areas, and the majority of the population is going to be living inside of that circle. So when we look into how cities evolved as through many vintages of technologies. Often those technologies, they were separated from each other, but cities, they're a system of systems. One system depends upon the other, so they have to evolve together. And that is the big problem that we have in the future on how to make sure that those systems, they work in an orchestrated way. So water depends upon, energy depends upon water, transportation depends upon energy. So how do we make sure that those systems, they operate quite well? And we do rely a lot on finite resources, and they're going to disappear. And we rely very, very little onto, very good other alternative sources of energy. And we are going to experience a very big scarcity in oil production in the upcoming years. So thinking about all this, how does success looks like for our planet? The 21st century is going to be the century of urban development transformation. We need to have a more integrated network of systems. So we have to have transportation together, exchange information with water and energy to ensure we have a better planet. We have to have adaptive, responsive infrastructure and do this in advance. So we have to have predictive maintenance to ensure that the systems, they operate and we can predict when they're going to fail, and have more cyber security, cyber physical systems, and rely more on a circular economy. And so looking at this represents a combination of data, disruptive technology, plus social innovation. So we have the facts that we collect from the urban environments, the raw data that can be transformed into information by giving context. We can extract knowledge and make informed decision. So how do we connect the bits and atoms? And that is the main idea for us on how we connect those systems. So it is predicted that by 2050, we're going to have 50 billion devices for 8 billion humans.
What are you referring to? Lorixa was switched, but if her video is off, then I cannot control her video, please. Also, look at stream when her internet seems to be low. Make sure I switched it in a second, and if her video is off, we cannot do much about it.
It's the medical flow that says that the powers of the connected network, the more nodes you have in the network, the more scalability you have and the more reach you have. Also, big data technologies also helps us pretty much into ensuring we can process all this data that we collect. And data analytics and machine learning is something that came in to ensure that we can make better use of the data. Let me give you an example of how systems they were created. Traditional systems before, they did not interoperate with each other. So you had to have a dedicated device with a proprietary infrastructure connecting with just one single application. And this is an example of a building, and where we have many systems around it. And all those systems collect data. But the problem is that because we do not are interconnecting those systems, people cannot draw much insights from what's going on. So for instance, if like a ventilator fails, how do we know the cause of that if we are not integrating all the systems? If the elevators stops working, maybe that is a problem in the power supply. So we have to go to many different dashboards for us to be able to collect insights. So the reconceptualization of those systems is to ensure that we have a single layer of integration where we can dump that data in through a connectivity layer that supports all the frameworks and all the protocols that we need to connect those devices and share this across different users and applications and stakeholders. So that is about having a connectivity, a network layer, and data as a service. And what it does to us is to help us to reconceptualize systems. So we have this, in the past could be just a lamppost, but today with the Internet of Things, what we can do, we can reconceptualize this lamppost and have this as a framework, as a structure to hold many other sensors. So we can have flood monitoring sensor attached to this. We can have emergency call sensor or buttons for people to press, fire call buttons as well. We can have parking monitoring also attached to this because of the power of 5G connection that we have, wireless network, and also the Internet of Things, because the cost of devices, they became quite cheap. And this is how we have those converged systems. So we have them connected through a network and a layer that interoperate those devices. So I have a few examples here. So on the top of the screen, on the top my left, you can see there's something as a tree. It looks like a tree. There's a project called Strawberry Tree, and that is a solar panel that collects energy from the sun and gives free energy access to the entire community where those trees are located. And down below, you can see like people can collect information about the weather, about the temperature, air quality. So people in parks exercise and they can make a very good use of that information provided by that solar panel. On the right side, we have a project called Big Belly, and the idea is not only to find whether a bin is full for logistics systems to come and collect it, but also to help people to understand how much they are recycling, how they do compare with other neighbors. So that helps with like changing behavior from users. Another project that's quite interesting that you look on the left is the Oxford Flood Network. So this is a sensor that stays on the Oxford Bridge Canal, and when there is a flood, that issues an alert to all the members of living in that canal, and the users of those sensors are the people who also own the sensor. So people are part of the network. They are part of the data processing. So they own the sensor, they care for this, and they feel they're empowered to also be change makers. On the left side, we have like this yellow box is like something that you can put on the pavement to detect whether that parking space is filled or not. And that can help drivers to not go and circle around, but to find location for them to park their cars. There's also a very interesting project by Ordnance Survey and Mobile Eye that is where they are running around the streets trying to map the assets that we have on the city, because by mapping the assets, you can also have a view of where we can intervene and where we can ensure that we have maintenance given at a particular time. So augmented reality is something that is also used on smart cities as well. So we have different types of mixed reality. So we have augmented reality, virtual, and mixed reality. The differences between is that the virtual reality, we're fully immersed, and the mixed reality, you are immersed, but you are still aware of the environment surrounding you. And this is an example of how that tackles the lack of doctors, and it uses augmented reality. So this doctor is in Bolivia. He doesn't know how to make an operation on a child. And there's a doctor on the other side of the planet teaching him with just the use of a tablet on where to make the stitches, on how to operate that child. And this is what we call Internet of Skills. And this is a project by Proximy, that they are looking into how to use augmented reality to help the Internet of Skills, people to learn on demand from different locations. And the complexity of data is increasing a lot. The more data we collect, the more the complexity of that data is going to be. And for the machine learning side, we understand that in traditional systems, we put the rules in the data, and then we code the rules. If this, then do something else, and then we get the answer. But in machine learning, the problem is like, we are not capable of writing all the rules ourselves. And in machine learning, we have a training system and a prediction part. And then we give to the machine learning the answers and the data, and the machine learning comes with the rules. And that is one of the things that we can use machine learning for us to empower the cities ourselves. Because at the moment, this is how the data landscape looks into cities, is very fragmented. And we have multiple stakeholders providing that data. And until the year 2011, 20% of the tasks performed by a machine learning algorithm, they were wrong. They didn't work quite well in classifying. But as 2017, 2% of the errors were provided by machines, which outperformed humans. We were getting the task of classification much poorly, like not much poorly, but with a certain percentage poorly than traditional systems. So the power of AI is something that can empower us into creating things like
and for providing
self-driving cars. So, and the idea of self-driving cars is for us to map the assets of the city, which is something the ordnance survey that I showed before they are doing, mapping those assets, understanding how to map people, and use next to understand how we can map the environment. And if you think about this, it's not for us to be on the car lazy, not doing anything, and the car drives by itself. Is that we have 60 million people on wheelchairs and 285 million people with visual impairment, and they need those technologies for them to take part into the city as well. Machine learning can also be used for us to predict lanes. For instance, this is an example of satellite image that we need to understand how many lanes we have on a street, but the trees there are occluding this, and how can we predict how many lanes we have in there and how many assets we have in that street. So we can use machine learning to detect what is behind this, and also how much 5G would be affected by this. Other example of using machine learning is to understand capacity and demand in cities. So this is an example of the infrastructure mapping application from the Greater London Authority. So those those pink dots, they are businesses opening up in the city by 2040, and those are housing. And you see in these red areas in this image, those are drainage capacity. So we see that we have planned the delivery of housing in locations that we don't have any drainage capacity. So that's the problem of not sharing enough information. So finally, I would just touch very briefly on the social innovation side. So OpenStreetMap is an open source technology that people use to drive adoption of maps in a way that everyone can contribute. So this is an example of someone going to a forum. When you look to the last image, you look from a satellite perspective, you think, oh, it's a straight street. But when you go there as a human, you see there's a stair. Someone on a wheelchair cannot take that. So we need people to feel empowered to contribute to those maps. And another project that we have that is quite useful to use humans as part of the data processing is called Blind Ways. So blind people, they often miss the bus stop and the location where they have to stop for the bus stop because GPS is not very good for micro navigation. So people have to go around and they miss the bus stop. So this Blind Ways project in Boston, people, they do record them going around on the street and recording, give 2 more steps, turn to your left, that is the bus stop, you stop there. So blind people, they can get this app and listen to the recording and the guidance of the person on that recorded that a particular path that the person wants to go. And that is something that is quite empowering, and is also something that we have to be very careful about how we ensure data, IoT, machine learning, the use of people as part of the data processing, but also to ensure that we build trustful and fair systems that we can also understand the traceability of usage. This is an example of Amazon same-day delivery. And if you can see, like most of those people in these areas, all of them, they were Prime customers, but only the blue areas that were served by the same-day delivery. But if you're a Prime customer, you should have access to the same-day delivery. But the gray zones, they were not served. And the vans, they would cross those areas and would not deliver anything there. and those areas, there are areas where African American they lived. So in their algorithms, they were collecting data which specified that people from that particular background, they didn't have enough income to support same-day delivery. However, they were prime customers. They were totally qualified for that. So we have to make sure we remove bias from the data that we have. And bias is something that is driven by data, from interaction, from assumption as well, from similarity. So for instance, machines can learn that if something happens in one case, it might likely to happen in another case. And we also have blind bias. So for instance, we also had the problem of Apple phone not being, you use unbalanced data sets for you to drive machine learning, and they didn't have enough samples of Asian people. So Asian people, they were unlocking each other's phone because the system could not learn very much about the facial features of them. So we have to be very sure that every single application we deliver will cater for the entire community and not be a commodity to be exploited and serve just a small proportion of the population. So what I want you guys to take from this talk is that we have all these problems happening in cities. We have technology that can help us. We have machine learning that can automate a lot of tasks, and we have the humans to help and to augment all this. And we can create new services and application, cross-sector value and value chains, and create jobs, innovation, and also drive competitiveness in cities. And I want to leave you with the key messages that we have to have, the key points that we have to have: be ethical by design, be secure and trustworthy, distributed and privacy preserving. So let's make it distributed, connected and distributed so we don't have a single point of failure. Not be fit for first world problem only, because for instance, London is a first world city, but in the next 10 years is going to experience water scarcity, which is a problem experienced by third world countries. So let's not only plan for first world problem like having Twitter drone going around. Let's plan for solving real problems, and be inclusive and transparent to serve all the users. And my last message is about the right to the city. It has to be the right for every single human, and ensure that all of them have access to this. We can use technology, data, and people. We have to keep in mind what is the population we are trying to serve. And that's the message that I had for today. Thank you very much for having me here.
I'm going to run through some of these questions if I can actually find them now. I'll just do them one at a time because we're obviously under set of time constraints. First one to you, Sarah. This is from Malcolm War. It says, I chair the UK COVID-19 Lessons Identified team. We've identified already major issues associated with the supply chain and procurement in ensuring UK remains resilient. Where do you see the balance between smart supply chain and human intervention in the supply chain?
Oh, wow, that's a question and a half. I think, as always, whenever we talk about smart solutions, robotics, this isn't completely replacing a human element. Taking a situation like COVID-19, where no one can even possibly comprehend this situation and everything that needs to be considered, that can't be trained into a system very, very quickly. You're always going to need to have some level of human involvement, of human interaction. So, I just think that the answer to that is really that the two systems need to work side by side. You can't just say, okay, now the robots take over and do everything. For something of that magnitude of importance, absolutely, you still need to have a human involvement and human-led.
It's interesting when you were speaking about Ocado, and you said they were losing thousands and thousands because they were picking up the wrong stuff and delivering the wrong stuff, or the stuff was in the wrong place. I thought, how many thousands would you need to lose before it's worthwhile hiring a human to do the same thing?
Yeah. And then that's up to the individual organisation to, I guess, to decide, depending on their profits, their margins. A lot of these solutions really are aimed at large organisations. That's where you really see massive, massive benefits. Most small businesses have a pretty good handle over all the different aspects end to end. When you get into that large environment, particularly, multi-region, multi-country, that's where I think having some kind of intelligence really does start to bring values in. If you are an organization that is looking at losses of thousands, millions of stock for whatever reason, then that is a real area where bringing in intelligence is going to make a massive, massive impact to you.
Yeah. Okay. Thank you very much for that. Next question to David. This is from Alan Ross, David. He says, it seems to me the Agriculture 4.0 approach outlined could have a massive impact on CO2 emissions from crop farming. Have there been any estimates of the impact on CO2 emissions if it's adopted widely in the UK or across other regions?
Not at national level, but we know that we can make the whole farm operate as effectively a carbon sink, also as a heat sink. In fact, the first system that we've sold to someone else up in Aberdeenshire, we sold to Martin Dickey, one of the founders of Brewdog. You'll see that they announced the Brewdog Forest this last weekend. And I think Martin actually sees the vertical farm as something complementary to that sort of behavior. So what we're doing is we're taking air or pure CO2 out of the system. The crop is absorbing all that carbon, and it's releasing oxygen, which we put back into a kind of gas mix again. So absolutely it can make a contribution, but we're going to have to get it at industrial sort of infrastructure scale before it's going to have a real impact.
Thank you very much for that. And again, I just love the idea of being able to sit there and develop a weather recipe. There's something almost about it, I think.
Yeah.
Now, Larissa, this is a question from Ryan Allen saying, you said that cars are not in use 90% of the time. Do you think with the development of self-driving cars, we could get to the point where cars are used in a similar fashion to the bikes and scooters found for rental in cities around the world?
Well, I think one of the things that we have to see from this is that ride sharing is something quite important because of this. So I think projects that helps people to not own the car if they don't need to. I think that is quite important. And on the second part, I think self-driving cars can also be something that can help people to be picked, but still work on a sharing perspective. So I would say that it can be helpful, but we are very far beyond that. And I'm not holding my breath for self-driving cars. I think if you look for the magic roundabout in Swindon, I don't believe a self-driving car could ever do that. We are very far away from this, especially because of the things that are intrinsic to the human brain, like the empathy and reading people. So I know I'm going on a tangent here, but I work with AI and ML, so I wouldn't hold my breath for self-driving cars. But I think what can really help us is to people make more use of ride-sharing initiatives, and to make sure that they own the car and they use the car when they need and as they need to do so, because that is one of the problems that we have. One driver in just a car that you could have 5 people. So it's for people to be more conscious about that.
There's a safety aspect to this too. I mean, I love him dearly, but I accepted a lift from my father the other day, who's 84 years old. He was driving, and frankly, the sooner self-driving cars come in, the better. Yes. Genuinely terrifying.
And I do believe that they are coming for this purpose, to help the people that have mobility issues or people who cannot drive anymore.
Yeah. The question here from Michael Bear saying, AI is reliant on data processing. Do you see the future lying in centralized data processing or in edge computing? I can't even begin to understand that question, but perhaps you will be able to answer it.
Yeah, I think one of the good things about the edge processing is that now at the moment we can process and have machine learning running at the edge. And the good thing is that you keep the processing close to the device, close to the people. And I think we are going to rely more on the distributed, running more things on the nose at the edge, especially because we need speed. So for instance, for predictive maintenance, if by the time we get the data from a device, send this back to the cloud and process on the cloud and bring the result back, that is the round trip can be too much, especially in critical mission things that we need, like we have to receive in milliseconds. So what I see is that we're going to move towards that much more into having, devices with more capabilities to have the processing on the device and also machine learning running on the device. So many of the frameworks that we have today for AI, for instance, TensorFlow, now we have version light of that you can run on the device. So you can do machine learning on a Raspberry Pi on a very tiny sensor to collect information from the environment. So I think we're going to move more towards that for mission critical things as well.
Yeah.
That's exactly what we're doing.
You want to expand on that, Sarah?
Yeah, so that's exactly what we're doing. All of our NVIDIA GPUs are exactly that, what Lewis was described. It's a different platform to Raspberry Pi, but all of the devices I showed in my talk have got an embedded GPU for exactly that, to do the processing on the device, so that the device isn't reliant on a connection to the data center, a connection to the cloud. It can be in its complete own environment with no connectivity and make decisions. On the self-driving car piece, we are working with over 300 automotive companies because, this is exactly the thing that they need to solve. How do you have cars that can make decisions that don't need a trip to the data center to figure out, do I stop or not? So I really do think there is going to be this massive move towards edge computing, particularly with the prevalence of 5G, to bring this smart world to life.
Yeah. Well, again, thank you so much to all three of you for putting up with the technical difficulties. I thought all three of you did a cracking job of actually getting your message online in the face of nearly overwhelming obstacles. So thank you very much again. And obviously, if you're just taking part in this as an attendee, thank you very much for actually taking the time to stick with it. It's one of those strange anomalies that the worse the technical situation gets, the more viewers we actually get. You can see the number clicking up in the top left-hand corner. I don't know how that works, but it definitely works. We're going to take a break now and do a full technical reset, let me assure you. We will be back, however, at 10:35, but until then, thanks very much for your attention.
Bye.
Thank you, guys.
Bye.